Good day, learners. Welcome to our mathematics lesson for today. My name is Nagile Ndlovu. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Our focus for today, boys and girls, is going to be statistics. You will remember statistics is a scientific method of investigation which involves data collection, data presentation, data analysis, and then from there we have data inference, which means generalizations. Now, there are so many ways in which our information or data can be presented. When we talk about data presentation, we have graphs like histograms, we have graphs like cumulative frequency curves, we have frequency polygons, we have pie charts. We have quite a number of these graphs that one may use depending on the type of information that you are dealing with. The whole essence of statistics is to carry out a research. For you to conduct that particular research, you need to collect information first. Otherwise, you can't just come out to the public and make a proclamation, make a statement, declare something without having collected information and analyzed it. So in statistics, we look at such kind of approaches. So our focus for today is therefore going to be the drawing of histograms after collecting our information, frequency polygons, and a cumulative frequency curve, which some people would call an ogive. Right, so by the end of this lesson, you are expected to calculate the mean of grouped data. You also need to identify the modal class for grouped data. Otherwise, you have been looking at discrete data. Otherwise, you also need to have a look at how you draw a histogram for grouped data, draw a frequency polygon, use cumulative frequencies to draw a cumulative frequency curve, which is also called an ogive. Use the ogive to determine the median, the lower quartile, and the upper quartile values. Then determine the modal class using a cumulative frequency curve. And we by now expect you to know how to calculate the mean of simple data, to identify the mode in a given distribution, and the median. You also know how to represent information using bars, that is a bar graph, pictograms, pie charts, like I've already alluded to, frequency tables, and stem and leaf diagrams, box and whisker diagrams. All these are the forms of data representations that you covered in previous grades. Right, we are going to define some terms here. Terms like continuous data. What do we mean by continuous data? This is information or data that take any number on a given scale of measurement. In other words, we're not only taking whole numbers in continuous data, we are also taking decimal numbers. For example, when you talk of distance, we don't measure distance only in whole numbers, as in counting numbers 0, 1, 2. We can also have 1,5 kilometers. In other words, we have fractional values involved there. Then we have a graph called a histogram, which is a diagram of rectangles whose area is proportional to the frequency of a variable and whose width is equal to the class width. So as we draw this particular graph, it is a graph that is made up of bars that touch each other. We have a reason why those touch each other based on the first point there to say is continuous data. So one bar connects to the other bar right up to the end of our classes. So our information in this case is going to be grouped into classes, and those classes will have some particular intervals. Right, the intervals may be uniform, they may not be uniform, but it depends on your data analysis and the way you decide to group your information. Then 3, the midpoint of a class interval is half the sum of the lower limit and the upper limit of the class. As you design your classes, there is what we call a lower limit, which is the smaller value of that particular class, and an upper limit. Some books, however, don't use the word limit, they would use the word boundaries. These are my class boundaries from 0 to 10, from 10 to 20, and so on. That's how you sometimes can create those classes. So the length of that particular class is called a class width. Right, a frequency polygon, therefore, is a closed shape drawn by joining points plotted using the midpoints and their corresponding frequencies. There is a reason here why we are emphasizing the word midpoints. We are going to look at midpoints at a later stage. Why would one talk about midpoints in grouped data, right? Then, what do we mean by grouped data? This is the data classification formed by putting individual observations of a variable into classes. In other words, you make an observation. Let's say you are looking at the distribution of marks in a particular examination. Those who obtained 0 to 10, you observe how many of those learners obtained 0 to 10, then 10 to 20, and so on until you get probably to 90 to 100. You are categorizing those learners as according to their individual performances. So each learner will fall into a particular class. There are reasons, however, why we group data in statistics. Each arrangement is called a group or a class upon dividing your observations into those particular classes. So the question could be, why then do we group data? Right, we are saying in each class there is a lower limit, a lower boundary or a lower boundary, and an upper limit or an upper boundary. But the question is, why do we group data? We shall have a look at that as we continue. Then 6, we are also going to have a look at what we call the cumulative frequency. What do we mean by the cumulative frequency? We are used to the normal frequency, which is to say how many got a 60. If there are 5, your frequency is 5. In other words, the mark 60 appeared 5 times. How many times did we see the red car as we are observing cars that are passing at a particular spot? The number of red cars that pass at that particular spot within a specified time interval will then define the frequency of those red cars. So in short, we have frequency. We also have what we call cumulative frequency, which is the sum of all the frequencies up to a particular value, up to a particular upper value of a given class. Our classes are 0 to 10, 10 to 20. We are saying up to 10, how many observations did you make? Up to 20, you skip all the lower boundaries and operate with the upper boundaries to say up to this particular upper boundary, how many people were now involved, or how many items were involved, or how many of those elements in our distribution were involved. So when we talk of cumulative frequency, we'll have to add up all the previous frequencies up to that boundary, upper boundary of the particular class which we choose to stop at. Right, then 7, what do we mean by a cumulative frequency curve? Right, a cumulative frequency curve is a curve that we can draw by plotting upper boundaries or boundary values against their corresponding cumulative frequencies. Yes, it might sound a bit of a theory here, but as we progress, you shall see how we apply some of these words and how we draw some of these graphs. Then, I already indicated to say sometimes we group our information and we don't take it as distinct values. There is a reason why we group data in statistics. We are saying it is a convenient way of analyzing or summarizing large volumes of individuals. Why would you put them in groups? Sometimes it becomes difficult, or rather cumbersome, a process wherein you want to draw and indicate the frequencies of 200 learners in an examination. And each learner has got their own mark. So if you were to draw a graph, it means you are obviously going to have 200 bars there. And most probably might even find that each bar will have a frequency of 1 because you are the only one who has that particular mark. And under each bar is going to be your name. So to avoid such, we sometimes decide as statisticians to say, why not group our information? Why do we group? It is a convenient way of analyzing or summarizing large volumes of individual observations. Instead of observing them as individuals, you'd rather observe them in groups, and you classify those groups accordingly. You don't just decide on a group. You have to classify them in or using a certain criteria. Right, then the question is, What are the disadvantages of grouping data? What could be the disadvantages of grouping data? Yes, we've seen the advantages. We are trying to eliminate those large volumes of individual observations and consolidate them into a group. Just like when you are in class, sometimes teachers put you in groups. It's for management purposes. They don't want to attend to individuals in that particular moment. They would put you in groups so that it's easy to give or allocate tasks to different groups. Probably they have more than one task to administer. So each group will work in a particular task. It becomes an advantage in that case. So as a statistician, you need to decide, should I group these, put these individuals in groups or study them as individuals? So the information that you are working with will always guide you and advise accordingly to say, is it necessary to put people in groups? But looking at the large volumes of data, it will always be wise to divide your data into classes. Those groups are called classes. So the worry now is what happens as we put observations into classes. The original information is lost. As the data set gets grouped and we count how many individuals or individual observations fall in that particular class. 0 to 10, how many of us got 0 to 10? I won't know what mark you got. I will only know in this particular group is 0 to 10. These three learners that I see in this group of 0 to 10, I may not know their individual performances. All I know is that in this class, there are only 3 individuals. In the next class, there are 5. But you will never know the actual observations unless if you were looking at the original data, which is what we call raw data. Raw data is that information you collected before classifying them into groups. So there is both some pros and cons in grouping data. That is advantages and disadvantages. The advantage is that it enables you to summarize or analyze large volumes of data by putting them into groups. Then the disadvantage now is that the original information is lost. That's the disadvantage of grouping data. Right, so we are presented with a table here. The statement reads, the table below shows the weight in grams that each of the 27 participants in the weight loss program lost over the 4-week period. Here are 27 participants who took part in a weight loss program. They were classified according to their weight losses between 1,000 and 1,500. Now, you must be very careful as you classify your data because you might have someone who lost 1.5 kgs, which is 1,500 grams. And I see in class 1, it says 1,000 to 1,500. If you don't look careful there, then the next class says 1,500 to 2,000. You realize that 1,500 appears in both classes, but there is a particular class in which you can't put 1,500. You must look into the way you have defined your classes using your inequality symbols. The first graph, or rather class, indicates that 1,500 is not accommodated in the first class because it says X is a number greater or equals to 1,000, meaning any person who lost 1,000 grams will qualify into that particular class. Otherwise, a person who lost 1,500 grams can't be found in the first class because that class is restrictive. It says strictly less than 1,500. You belong to that particular class exactly from 1,500. Those inequality symbols are not there by default. They are there by design, so that we can know where to place 1,500 if it happens that we have a 1,500 amongst the observations. Yes, so our first class says 1,000 is less or equals to x, then less than 1,500. The next class is now going to accommodate that 1,500 is less or equals to x, which is less than 2,000. So when you check all your upper boundaries, these are your upper boundaries, upper boundaries, upper boundaries, the upper values for each particular class. Otherwise, on the other side, left-hand side, we have our lower boundaries. These are what we mean by the limits to a particular class. Each class has got its own limits. Each class tells us where to start and where to end. Are we accommodating 2,000 or not? Are we accommodating 1,500 or not? We apply our knowledge of inequalities. Those are inequality symbols. One part of an inequality symbol is a half inequality symbol, the one that says less or equal. It means it's accommodative of that particular number. Whereas the other part, which is a strictly less than symbol, won't accommodate the given value. Right. So we have here a total of 1, 2, 3, 4, 5, 6, 7, 8 classes. So in the first class, the observations were 2. In other words, of those 27 participants, 2 fell in the first class. In other words, they lost between 1,000 inclusively to less than 1,500. In the next class, the frequency is 3. In the third class, the frequency is also 3. In the fourth class, the frequency is 4. In the fifth class, that's where we are recording the highest frequency of 7. In other words, between 3,000 and 3,500, including 3,000, we had 7 participants who lost between 3,000 and 3,500 grams of their weight. Now, if you add up all those numbers under frequencies, they must always correspond to the total, meaning your 2 plus 3 plus 3 plus 4 plus 7 plus 5 plus 2 plus 1 should give you exactly 27 participants. This is another way of checking if you have accommodated all your participants in that particular program. But all we are emphasizing here is that we are talking of 27 participants. So whoever is conducting this research is decided to put these people into groups. Those who lost so much, those who lost so much. And as you can see, we don't know in the first class of those 2 participants how much did each one lose. All we know is that between 1,000 and 1,500, there were 2. We don't know whether both of them lost 1,000 grams or one lost 1,000 and the other lost 1,200, but as long as it is less than 1,500. All we know is that there are 2 in that particular class. Only them know what they lost. Because the data collector simply said, those who lost between 1,000 and 1,500 stand there. We saw 2 people moving. Between 1,500 and 2,000 stand there. We saw 3 moving. It's only them who know what they lost. Otherwise, in our case, we only know their mark or loss is between these 2 particular values, which is what we indicated earlier on to say, yes, in as much as it is an advantage or is advantageous to put information in groups, the danger is that we lose the original information. That's what we meant by saying these are the disadvantages of grouping data. We tend to lose the original information, especially if you don't have the raw data. You are just but presented with a frequency table. Okay, right, we proceed. According to the questions, we need to determine what they call the modal class of the distribution. Which one was the modal class of the distribution? Remember, here we are not talking of individuals. We are talking of classes. We are talking of groups. We are talking of group A, group B, group D. Which group performed better of all of them? So here we are talking of classes. The first class, the second class, the third class, or the groups, since we have put our information or distribution into groups. So of all those classes that we have, which one has the highest frequency? We still maintain the same interpretation of our mode, the same definition of our mode. What is a mode? in statistics. Yes, thank you. A mode is the highest frequency, or is the observation that has the highest frequency. It is the most appearing information. So in this case, we don't know the most appearing information, but when we look at the groups, all out of all the 8 of them, we see that group 3,000 to 3,500 had the majority of those participants. So when the question says determine the modal class, they didn't say the mode as in a number, they said modal class. So it means we have to take a class as our mode. So those are some of the questions that you need to answer. That is number 1. Then number 2, which seems to be a bit challenging, a question for 3 marks. It says calculate the approximate mean. They didn't say calculate the mean for an obvious reason. We don't know the actual weight losses. All we know are the classes. Hence, the question will always say in grouped data, calculate the approximate mean. In other words, it's not an actual mean. It's an approximated mean. It's an estimated mean of the mean weight loss in grams of the 27 participants over the given time period of 4 weeks. Then question number 3, use the information given on the frequency table to draw a histogram. So it simply means in number 3, this information that we have put into classes enables us to draw a specific type of a graph which is called a histogram. It's a specific type of a graph that we call a histogram. All histograms that are drawn in statistics always represent continuous data. Weight loss is continuous because we're talking of grams there. We're not saying you're going to lose only 1 kg, you're going to lose only 2 kgs, you're going to lose only 5 kgs. You may as well lose 3.25 kgs. It's accommodative of decimal values. So on that note, it means weight is a continuous variable. Weight is a continuous variable, meaning it can assume decimal values as well, not only whole numbers. Then question number 4, use the information on the frequency table to draw yet another graph, which this time they call a frequency polygon. So far, I think you are seeing 3 graphs there. You have seen a frequency table, which is the graph that we started with. This is a frequency table. It indicates how many people appear per particular class. Next, we are going to see a histogram coming from the same information. And then, lastly, you are also going to see what they call a cumulative frequency polygon. We may as well add a 4th one, which is your cumulative frequency curve. All these are modes of data representation, and they are interpreted differently but representing the same information. They will yield the same result depending on what information you are looking for. Right, so let's have a look at our solutions. I want you to go back to the table and quickly identify for me what they call the modal class. I will also add something there. The modal class. Which one is our modal class? And I'm emphasizing modal class. And you'll realize here as you are answering this question, this is one of the topics where we collect marks even at matric. So starting from today onwards, make sure you practice as much as possible of these questions. You shall reap very good results from this topic. Many a times learners get almost everything correctly there. So love the topic. It's quite an interesting topic. So which one is our modal class? Yes, thank you. There is our modal class. The modal class is X is a number greater or equals to 3,000 but less or equals to 3,500. 3,500. So it means the majority of the participants were found in this particular class. They lost about from 3,000 up to less than 3,500. That was the majority. That's what we mean by the modal class. The other question that I would have asked you here was to say, determine the mode of the distribution. Without saying modal class, how would you find the mode? But the values are not there. You can't identify which weight loss appeared the most, but you can see the majority are in this class. Let's answer this question after the next part of the presentation. How would you determine only the mode of the distribution without saying modal class? There is a difference between the two. If a question says determine the modal class, you give us a class, like 3,000 to 3,500 is a class. But when the question says the mode, how do you answer that question without the word class? Okay, we shall attend to that question later. Right. Probably after question number 2. In question number 2, you want to find the mean of your distribution. It's an approximated mean. It's not an actual mean. Remember, we said there are 2 here. We don't know their actual weight losses. So how would we add up all the weight losses and divide by 27, which is our x bar, the mean? That's how we find the mean in statistics. You add up all the individual observations, divide by the total. Basically, when you are finding the mean, you are leveling the ground. You want to allocate all of them the same number. We don't want some having 3,5 grams weight loss, some having 1,8. We want all of them to lose the same amount. That is what we mean by the average mean. You add up all the values, then divide by their total. Unfortunately, we don't have something to add here. So the question is, how do we find the mean of grouped data? The values are not there. How would you find the mean of that grouped data? Okay, I'm going to pause there and give you a few minutes. I want you to think critically about this. Who are these 2 numbers, or which are these 2 numbers that I'm going to add here? Which are these 3 numbers in the next frequency that I'm going to, and so on until the last one. Which ones am I going to add together? Because they are not there. I have lost that information. All I have are classes. So how would you find the mean? Right, I will guide you. When data has been put into classes, the best is to work with what we call a midpoint. A midpoint being the value that is in the middle of 1,000 and 1,500. You start listing numbers from 1,000 up to 1,500 and determine which one is in the middle of 1,000 and 1,500. That's what we mean by a midpoint, the middle value of that particular class. And you remember something. When we put you into groups, I have never seen a leader of that particular group seated at the end of the group or on either end of the group. Usually leaders sit in the middle to control the group. So in statistics, when we are dealing with grouped data, we have to locate a value or a number that is in the middle of our lower and upper boundary. We locate a number that is in the middle of our lower limit and upper limit. So in this case, we're going to take our calculators. I'll lead you with the first one. You take your calculator, you add 1,000, switch it on, 1,000 plus 1,500. I guess this is reminding you of something, the midpoint formula in analytical geometry. You want to find the mid value of 1,000 and 1,500. You add those 2, that's 1,000 plus 1,500. You get your total, which is 2,500. Then you divide by 2. I'm getting 1,250, which means the middle value here is 1,250. That is my first number as a midpoint. I want you to quickly finish off the table on your own. Find the next midpoint right up to the last one. Let's proceed and complete the table. Only the midpoint. Don't worry about the rest. Only the midpoints. I want the midpoints, the middle value for each class. And you are going to observe something as you are doing that. Let us work, boys and girls. Learn to focus and work on your own. There shall come that time where you'll consult. I have given you a lead. Your midpoint there is going to be 1,500 plus 1,000 divided by 2. What I'm saying is you add 1,000 for the first class plus 1,500. Then you divide this by 2. Start by adding those two, then divide by 2. It will give you the middle value. Okay. Do the same for all the classes, upper plus lower, divide by 2, upper plus lower, divide by 2 throughout. You'll get those missing numbers there. If you have just joined, we are determining the midpoint of each class. The frequencies are given, so we want to calculate the mean, approximated mean for our distribution of those 27 participants in a program. Unfortunately, the numbers are not known, but we can always come up with their representations, which are midpoints or mid values. Yes, thank you. Right, so you'll realize that, for instance, if I may go back here, the next class you are going to add 1,500 plus 2,000, it gives you 3,500. Then you divide by 2, I'm getting 1,750 here, 1,750. The next one I add, I get 4,500 divided by 2, because we have added 2 numbers, that's why we are dividing by 2. I'm getting 2,250, 2,250, and I'm going to stop there and ask a question. I want you to look at the gap between those midpoints and see if there is uniformity there. 1,250, next 1,750, next 2,250, and so on. What are you observing as you go further down? Yes, you'll realize that if your class intervals have a uniform width, meaning from 1,000 to 1,500 there is a gap of 500. From 1,500 to 2,000 there is a gap of 500 again. When you look across or down the classes, there is a gap of 500 throughout. So it means even the midpoints will maintain the same gap. That's the beauty of mathematics. There is always uniformity in what we are doing. So we are going to add 500 to the previous, 500 to the previous. So my next number, I'll add 500. It will give me 2,750. Next, I add 500 because it's uniform throughout. It will give me 3,250. Next, I add 500, the same class width for the classes. It gives me 3,750. Next, I add 500. It will give me 4,250. And final, 4,750. You can confirm by taking the last class, which is 4,500 plus 5,000. You will get 9,500. Divide this by 2, it will give you 4,750. So it means now that our information is lost, we have no choice but to allocate per class 1,250 for the first 2. Each one of them will be allocated 1,250, meaning they lost 1,250 grams. The next class of those 3 participants, each one of them will be allocated 1,750, and so on, because we have lost their marks. We have, their masses or weight losses. So we are going to allocate them the middle value. No one can complain because we have taken a value that sits in the middle of their class, which serves as the leader for that particular class. So whenever you are determining an approximated mean for grouped data, first things first, determine your midpoints. They may not always be uniform in terms of the gap or in terms of the interval, but you have to add the upper and the lower, divide by 2, upper plus lower, divide by 2 throughout for each class. But should you realize that there is uniformity, you can just determine the first one and keep on adding that uniform gap. But get used to the formula is the lower limit plus the upper limit divided by 2. It will never fail you, regardless of how the classes have been designed, whether there is uniformity or non-uniformity. Right, having said that, you'll then say 1,250 multiplied by 2 added to 1,750 multiplied by 3 added to 2,250 multiplied by 3, and so on until the last midpoint, which is 4,750 multiplied by 1. That will give us the total weight losses as in approximation, then divided by the total number of participants, which is 27. So simplifying the numerator, you are getting 80,250, then divide by 27. So it means on average, the participants lost 2,972.22 grams. That's how you collect your 3 marks. So we'll always give you a mark for the midpoints and the corresponding frequencies in multiplication, and then a mark obviously for dividing by 27. Then the third mark will go to the final answer, correct to 2 decimal places if the degree of accuracy is not specified in the question. Otherwise, if it's a whole number, it's actually an advantage. Okay, so this is how you calculate the mean for grouped data. You will never be successful in calculating it because the data has been lost, the information has been lost. So the best is to locate the midpoint, which is found by saying lower boundary added to upper boundary of each class divided by 2. Get that number, get all those numbers, then multiply them by their corresponding frequencies, and then divide by the total for 3 marks. Right, our next question, it required us to draw a histogram. That was our next question. It says, draw a histogram. Use the given information to draw a histogram. This is a type of a graph that uses rectangles, and those rectangles have a height which corresponds to the frequency of that class and a width which is the class interval. Like I indicated earlier on, you'll be fortunate to get a histogram which maintains the same class width, meaning all your bars will be of the same thickness or width. They will be equally wide. But going up, it will depend on the frequencies for each particular class. So having said that, and I requested that in today's session, you bring a grid of some kind or a graph paper of some kind. This is a graph that is drawn on a proper scale. You need to identify a scale that you are going to work with. My first number is 1,000. I may choose a scale like 0, 500, 1,000, 1,500, and so on until I reach 5,000. You are going to space out your numbers accordingly. But many a times in examinations, a graph paper is already provided for you. Yours is to draw the bars and attach the corresponding frequencies. So in this case, since you don't have that graph drawn for you, you are going to design your own there quickly. The vertical axis, you are going to have your frequencies. The highest frequency is a 7, if you look at the table. And then across the horizontal axis where you are going to have your weight loss over 4 weeks, you are going to start from 0, 500, 1,000, space it out until you get to 5,000. Let's quickly do that. Come up with your Cartesian plane, wherein on the vertical axis, you are going to have your frequencies. Yes, this is going to be your frequency going up. This is going to be your weight loss in grams. Then you are going to have your 0 there, 1, 2, 3, going up until you reach 7. And then across, you start from 0, go to 500. Next, you go to 1,000. Next, you go to 1,500 until you have covered your 5,000. That's the scale that I want. From there, you are going to say from 1,000 to 1,500. What is the height of that bar? Then you start drawing your bars. Start drawing your bars. Right. There is your solution. This is what we mean by a histogram. It is made up of rectangles. The height of each rectangle corresponds to the frequency for each class. Our scale runs from 0, 500, but I didn't indicate that 500, 1,000, 1,500, 2,000, 2,500, up to 5,000. Our first class starts from 1,000 and stops at 1,500. The question is, why do these bars touch each other? Remember, where one class ends, another class begins. Where one class ends, another class begins. And our bars, in this case, they are of uniform width because the class width was the same. It was 500, 500, 500 throughout. If it happened that there was a class that was wider than 500, we'd even see it here because the base of that bar would be more than 500. It will look wider than all other bars. So a histogram of this nature indicates that there was a uniform class width. In other words, all classes were having the same difference of 500, 500 in this case. Then going up is our frequency up to a maximum of 7. Now, remember what I said earlier on. Each graph is interpreted differently. When you are using a frequency table, you look at the highest frequency in terms of the most appearing. How many participants did we have as in majority? It was 3,000 to 3,500. When you are using a histogram, the modal class is the class that corresponds to the highest frequency. In this case, it's the class that is the tallest of them all or highest of them all. So the class that is the highest of them all here is from 3,000 to 3,500. Again, is indicating to us that the class remains 3,000 to 3,500. When we looked at the frequency table, that same 7 was corresponding on the table to the same class. When we come to this new graph that we call a histogram, this bar shoots up higher than any other bar. Hence, that indicates our modal class. I indicated earlier on to say sometimes they don't say modal class, they will say determine the mode. This is where you will go back to that class and say the mode is a modal class. The modal class, we already saw it, is 3,000 is less or equals to x, then less than 3,500. That's your modal class. But if a question says determine the mode, this is where you are going to say mode is an approximate value. You add the two, 3,000 plus 3,500. Oh, it's the midpoint of that particular class. Then you add the two, that gives you 6,500. You divide that 6,500 by 2, it will give you 3,250. So if a question says determine the mode and they don't say modal class, you have to find the midpoint for that particular class where your mode is. The most appearing, they are in that particular class. So there are two ways in which that question can be asked. But all in all, what we are saying here, as you draw your histogram, the bars will always touch each other. As compared to a bar graph leaves gap because the information is not continuous. A bar graph is used for discrete data that can't overlap into another class. The moment you make bars touch each other, you are saying it's a continuous variable. Otherwise, if you're just noting colors, black, how many are black, how many are red, how many are green, each bar will stand on its own. As you draw that bar graph, you maintain the same thickness of the bars and maintain the same gap between the bars. In a bar graph, the bars will always leave a gap, whereas in a histogram, it's a special type of a graph that is focused on the areas of each rectangle. The areas are not going to be the same. The one graph that has the biggest area is where the majority were. So in this case, you can see 3,000 to 3,500 had a maximum of 7. That is the area of that particular rectangle. Okay. Then our next question wanted us to draw what we call a frequency polygon. I'll go through this one with you. How you draw a frequency polygon is still the same graph. This time around, I've used a totally different graph paper. I have drawn the same histogram that you saw in the previous graph. We now want to draw what we call a frequency polygon. A frequency polygon can be superimposed on a histogram. It can be drawn on a histogram. From the word polygon, a polygon is a closed shape made up of straight sides, starting with a triangle moving onwards. It is a closed shape made up of straight sides. So as you draw this polygon, at the back of your mind, you must say, I'm going to produce a shape. I don't know what kind of a shape it could be, depending on the number of sides. So the question is, how is a frequency polygon drawn? We are going to draw it in two ways. Way number one, we use the midpoints of each bar. So we are going to mark the middle value here. We mark the middle value there. We mark the middle value there. We mark the middle value there. The middle value. You mark at the center of each bar. You mark the center of each bar. From there, you join those points by using a straight edge. Use a ruler to join those points. You take your ruler, you join the points. You join the points. At the end of the day, having joined the points, you will produce a shape like this. This is how you can draw a frequency polygon on a histogram. As long as the histogram was correctly drawn, you go back to that histogram and identify the midpoint of each bar or of each rectangle. You'll realize that it will hang, that graph will hang. It hangs here. That is the first point that you marked. And this was your last point that you marked. But remember, it's a polygon. It has to be a closed shape. The other side that completes it is your horizontal axis, which is this black line there, your horizontal axis, to make it a complete shape. But since your first point was this point, you need to ground this polygon. Just like when you ground other graphs that you shall see later on. You need to ground this polygon. Some books will leave it hanging, starting with a height of 2 there, and then ending with a height of 1. But it's advisable to always ground your frequency polygon. How then do we ground it? You look at the lowest point that you marked, which is 1,250. Remember, our midpoint for this class was 1,250 going up there. That's 1,250 versus 2. The next point was 1,750 versus 3, and so on. You are marking basically the midpoints versus frequencies. Then for you to ground this polygon, you look at the previous class. The previous class was, of course, not part of our observation, because our observation started from 1,000 going upwards. But you always consider the previous class, which has a frequency of 0, 500 to 1,000. It wasn't part of our distribution because its frequency was 0. In other words, no participant lost that amount of grams. So you are going to ground in the middle of the previous class. Between 500 and 1,000, there is 750 at the bottom here. That's where you ground it. Then further up, our last point was that 4,750, our midpoint, which was 4,750, that was our last midpoint there. So it means our last point was 4,750 and 1 as a point, as an ordered pair. So it means by right, our frequency polygon should have stopped at that midpoint. But because of grounding, we look at the next class, which is from 5,000 to 5,500. There is now 5,500. Again, there was no one in that class. The frequency was 0. So you ground it in the middle of this, which will give you 5,250. So when you ground your frequency polygon, you always look at the previous class. You go and locate the middle value for that previous class, ground it at the bottom there on the horizontal axis. Then you go to the upper boundary, the upper or last class, which was your highest class, which was 4,000 to 5,000. The midpoint there, we said, is 4,750 versus 1. But then if we leave it at 4,750 versus 1, it is going to hang. So we need to ground it on the horizontal axis. How do we ground it? We look at the next class and mark the middle of that class, which is 5,000 to 5,500. In the middle, we're 5,250. That's where you're going to ground it down here. If you are using your histogram, this is called superimposing a frequency polygon on a histogram. At the end of the day, you are going to have a 2-in-1 graph. In other words, there is a histogram as well as a frequency polygon, which is a shape formed by joining the midpoints of each rectangle using straight lines so that it agrees with what a polygon is in these other grades. Okay. Alternatively, you can mark all the points. Remember, our first point was 1,250 and the frequency was a 2. You mark that point. Next one, you mark the point. You mark all the points versus their midpoints until you mark the last one, which was 4,750 and 1. This was your last point. Otherwise, the middle point is the one that corresponded with the highest frequency of 7, which we said is 3,250. You mark all your points in terms of the classes. Then from there, you join those points using straight edges. Then you ground by starting from the point here, then go straight down to the middle value of the previous class of 1,000 to 1,500. The previous class is 500 to 1,000. You mark in the middle of that class. The last class, which was not part of us, is 5,000 to 5,500. You mark in the middle of that class, then you ground your frequency polygon. As simple as all that. But the scale is also important. It's a frequency polygon, so you maintain your frequency. So for one to successfully draw a frequency polygon, they need the following. You need the midpoint of each class. You need the frequencies. You obviously need a graph paper and a ruler. This is the only graph that is drawn using a ruler as compared to other graphs that need curves, a smooth curve. This one you need to join the points using a ruler so that it becomes a polygon. All sides must be straight edges, no curve. You move from point to point, point to point until the last point, and it will always hang. That graph will always hang. It's your duty now to ground it. How do you ground it? You look at the previous class or the class that comes after the last class. Then you ground it in the middle values for those two classes, upper and lower. Never ground it to the starting point 0. You always look at the next class before the actual class or the next class after the last actual class. Never ground it to 0 because your graph starts at 0 or your scale starts at 0. You always use midpoints going backwards, midpoints moving forward. So the first midpoint before we get to 0 is 750. That's where you're going to ground your graph. Okay. Then we are going to move on to the next graph, which is called a cumulative frequency curve. A cumulative frequency curve. So far we have done 2 graphs. We did the calculation of the approximated mean for grouped data. We used the frequency table to draw a histogram. We have drawn a frequency polygon. We now want to have a look at this other graph, which is called a cumulative frequency curve. And as the name suggests, you can't use a ruler to join such points. You have to make it a curve, a smooth curve. We shall see what kind of a curve is produced under cumulative frequency curves. Right, the question is, what is a cumulative frequency? We did indicate earlier on that it is the sum of all the frequencies up to a particular upper value of a given class. It is meant to analyze how many individual observations are there up to a particular value. Up to this value, upper value, how many observations are there? Up to this value, how many observations are there? Up to 10, how many learners do we have? Up to 20, how many do we have? Up to 30, how many do we have? Up to 40, how many do we have? That's what we mean by cumulative. We are adding up all the observations up to a particular number. So when I say I have divided my classes into 0 to 10, 10 to 20, 20 to 30, and so on. When I say up to 50, what does that mean? It means I have to add up all the frequencies and build them up until I get to 50. I'm basically looking at all the observations that were made from the beginning up to where we are, which is 50. That's what we mean by a cumulative frequency. There is a normal frequency, which speaks to a particular class or which speaks to particular observations. Then there is a cumulative frequency, meaning you are summing up to a particular point, and then you stop there. And that particular point is always your upper boundary. It's always your upper limit. You never stop at a lower limit. You always use upper limits. Up to this upper value, how many fell there? Up to this value, how many fell there? So that's basically what a cumulative frequency is all about. So this cumulative frequency is the one that is going to allow us to draw what we call a cumulative frequency curve, which some people call an ogive. Some say ogive, whichever way you pronounce it, but you must understand what you are drawing. You are drawing a graph that uses cumulative frequencies. Okay. Right. We are presented with this question also. It says the table below shows the marks in percentage obtained by 40 grade 9 learners in a mathematics Olympiad. These questions are very tricky. You must read carefully and understand. It says 40 grade 9 learners. You find some of us dividing by 9. That 9 is just indicating the grade. It has nothing to do with the observations. There were 40 learners who were observed. So meaning you can confirm by adding those numbers 4 plus 5 plus 9 until you get to 1 and see if they build 40. Otherwise, it's not 9 learners. Sometimes we don't read careful. You will end up sitting with 9 learners instead of 40 learners. It says obtained by 40 grade 9 learners. That grade 9 learners is just but a name for the learners. It's a grade 9 group of learners. Right. So the marks are classified according to some intervals. Our first interval says x is a number greater than 0 or equals to 0 but less than 10. In short, these are learners who obtained less than 10 but from 0 up to less than 10. There were 4. Then from 10 to 20, there were 5. From 20 to 30, there were 9. And from 30 to 40, there were 7. Then from 40 to 50, there were 7 again. From 50 to 60, there were 5. 60 to 70, there were 2. Otherwise, 70 to 80, there was only one learner who probably, actually it's not even a distinction because it says less than 80. Must be careful with the inequality symbols there. So this learner got above 70 but did not reach 80 because the inequality symbol says less than 80. So the upper values are using less than. The lower values are using less than or equal to. Why is that so? Because we don't want a problem of that 10 appearing in the first class and in the second class, and we won't know where to place that child. Hence, one class must accommodate 10, the other class mustn't accommodate 10 to avoid double booking a learner or double allocating a learner a class. You must be allocated to one specific class. So the way you design that interval, it must take into account of such. Right, we are going to have a look at what we call cumulative frequencies. On cumulative frequency, we look at the upper boundaries. These are your upper boundaries. So you are saying up to 10, how many learners were there? I'm now under the cumulative frequency column. Up to 10, there were 4. There were still 4 up to 10. Next, up to 20, I'm going to do up to 20. Then you continue with the table until you get to the bottom. Up to 20, we are now including 5 because there are these 5 that are joining who are in this second class. So when I say what is the cumulative frequency up to 20, it means I'm looking at all the learners that were there scoring below 20. All those that scored below 20, you say 4 plus 5. That gives you 9. So there were 9 now. Up to 20, there were 9. How about up to 30? Where you ended in the previous class, you take that 9 plus 9. You add the new 9. So they are now 18. They are now 18. That's what we mean by cumulative frequency. It's building up towards the total of 40, which is all the learners who scored up to less than 80. So when we talk about the cumulative frequency, we are looking at each class at a time. We are saying for the first class, the maximum is a 10 that one could have obtained less than 10. So how many learners scored up to less than 10? There were 4. In the next class, we are saying up to 20. How many were there now? Is 4 plus 5, which is a 9. Then up to 30, how many were there now? It's going to be the previous 9 plus the next 9, which is an 18. I want you to complete the table right up to 80. How many participants were there in each upper limit? Let's quickly complete that table. Yeah, you can quickly take down the table. You can see it on the screen there. Put your intervals and then complete that table. This is where you normally earn your first 2 marks when you are drawing this graph. Completing the table successfully so will earn you 2 marks. We are not going to allocate 1 mark for each correct answer. We tend to group our cumulative frequencies. Up to this point, if it's correct, 1 mark. Up to this point, if it's correct, 1 mark. As long as I see 4 and 18, 1 mark. Next, as long as I see this up to this, another mark. It can carry a minimum of 2 and a maximum of 3. So let's complete that table. You can't draw a cumulative frequency curve without this particular column. You need a third column, which is called the cumulative frequency column. Yes, continue working until you get to the last class, which is 70 to 80, but you are focusing on up to 80. How many learners were there? And you will see or observe something by the time you get there. Yes, thank you. From here, what did you say? 18 plus 7, it gives you 25. So up to 40, they were now 25. Next, yes, 25 plus 7, it gives us 32. Next, you take your 32 plus 5, it will give you 37. Next, you take your 37 plus 2, it will give you 39. And final, you take your 39 plus 1, it will give you a 40. Oh, this 40, it agrees with the number of learners that were involved in this particular Olympiad exam or test. So every time you do your cumulative frequency, you are saying by the time you get to the maximum upper boundary, everyone is involved. So it gives us portion by portion until we get to the last one. By the time we get to the last one, it must always agree with the number of people that are taking part in that particular examination. Okay, so this column that we have designed here, 4, 9, 18, 25, 32, 37, 39, and 40 is called a cumulative frequency column. So we might give you a mark seeing this 9, 18, 25 from 4, and you'll notice something again with this cumulative frequency. The leading number under frequency becomes the leading number even under cumulative frequency. That is always your starting point. In this case, the leading number under frequency is a 4. The same 4 is going to lead under cumulative frequency. Then thereafter, the numbers will start changing as you add class by class, class by class until you get to the last number. That's how you design your cumulative frequency. So maybe from the 4 up to 25 is a mark, then from 32 up to 40, another mark. That's how we normally mark this question. We need to see certain numbers there. Okay, unless if there are questions, let's proceed. Right, so the first question says, complete the cumulative frequency column. We have done that. Draw a cumulative frequency curve. 3 marks for that. Drawing it, 3 marks for that. Determine the median mark, who was in the middle, or what mark did the middle learner obtain. Then use your ogive to determine the interquartile range. We're also going to have a look at how you use the cumulative frequency curve to determine the interquartile range. You already know the interquartile range from box and whisker diagrams, but this time around we want to have a look at how we determine the interquartile range using a totally different graph altogether. Right. The question is, how do we create a cumulative frequency column? We have already explained that. You start with the frequency for the first class. You keep on adding the next frequency to obtain the cumulative frequency for each class. Then the final cumulative frequency should always correspond to the total observations made. Right. So having done that, this is what you should have obtained there, which is exactly what we did together. That's how you draw up your cumulative frequency column. And then the next question requires us to draw a cumulative frequency curve. I want you to take your graph paper. You come up with a scale starting from 0 up to 80. From there, you will have your cumulative frequency column upwards, and the highest number should be 40. You can move in 5, 10, 15, 20, 25, 30, 35, 40, and stop there. That is your vertical axis. In other words, you are going to have your vertical axis and then your horizontal axis. 0, maybe 5, 10 or 10, 20, 30, 40. But if I move in 5s, I'll say 5, 10, 15, 20, 25, 30. 5, 10, in this case, I used 5. Yes, 5, 10, 15, 20, 25, and so on. Across, I used 10, 0, 10, 20, 30, 40, and so on. That is how you are going to design your scale on your graph paper there. Then you are going to label horizontal. This is your class interval. These are max class interval. Or rather, let's say max, because we are talking of the max obtained in that exam. These are your max. Then these are max as a percentage. Then up there, you will write cumulative frequency going up. Let's quickly have that scale on your grid. 0, 5, 10, 15, 20, 25, 30, 35, 40 going up the axis, across 0, 10, 20, 30 until you reach 80. That's your maximum number there. All right, so you have a problem here and you need to listen very careful. Many a times learners lose marks here because they will draw this graph using wrong numbers. Remember, when we were constructing our cumulative frequency column, we were saying up to 10, up to 20, but the danger now is I see two 20s. There is a 20 as a lower, there is a 20 as an upper. And when you look at the whole table, you can match and pair up numbers here. As you draw your cumulative frequency curve, you focus on the upper boundaries. In other words, you'll have to have ordered pairs. Your first pair is going to be 10 and 4. You take the upper numbers. Never draw this graph using the lower values. You always use the upper limits. It's an upper cumulative frequency curve, meaning as you draw it, the points that you form, they must follow upper boundaries. So your first point that you plot should be 10 and 4, not 0 and 4. Because we're saying up to 10, we did not say up to 0. We said up to 10, there are 4. Up to 20, there are 9. Up to 30, we are using the upper boundaries. That is very, very fundamental as you draw this cumulative frequency curve. So your first point should be 10 as an upper boundary and a 4. The next one should be 20. It should be 20 and your 9. That's the point that you are going to plot. The next one should be 30 and 18, up until you get to 80 and 40, which will be your last point. It will be 80 and 40. You are using upper boundaries. It's standard. That's how it's drawn. You don't cherry pick and say, today I'm going to draw it with the lower boundary. It's going to, yes, produce a curve. That curve is using a less than or the lower limits. All cumulative frequency curves are drawn using the upper boundaries because they are adding up to that particular upper value for each gas. Otherwise, if you don't do it properly, you'll find yourself having 0, 4, 10, 9, 20, 18 instead of 10, 4, 29, 30, 18, 40, 25. You move with the upper boundaries together with your new frequency, which is called the cumulative frequency. Hence, the graph is called the cumulative frequency curve or ogive. Okay, then I want you to quickly plot your points now. 10, 4, 29, 30, 18, 40, 25, until you get to 80, 40. Right, having plotted your points, there is my first point is 10, 4, next point 29, next point 30 and 18, next point 40 and 25, next point 50 and 32 are moving with the upper values. Next one is 60 and 37. Next one is 70 and 39. And final is 80 and 40. Those were the marks versus the cumulative frequency. Right. We have plotted exactly 1, 2, 3, 4, 5, 6, 7, 8 points. Those 8 points correspond to our 8 classes. There were 8 classes there. Right, you'll realize that these points are bending out to form a curve. We don't join the points using straight edges here. It has to be a smooth curve. You join the points by using a curve up to there. You use a curve, you bend around or follow the points, one point after the other, until you get to the first point. Let's do that. join those points until you get to the first point. You try to connect the points using a smooth curve, not straight lines. And you continue drawing the curve. Don't stop in between, because the moment you stop, you are forced to join them using a straight line. You just have to curve through each point until you get to the first point. Yeah, they may not align properly, but try to form a curve of some kind. Right. You'll realize that having done this, join the point, yes, that's your cumulative frequency curve. But we have what we call grounding of the curve, just like grounding of our polygon. This curve needs to be grounded. When we say you are grounding your cumulative frequency curve, it means you are taking it to the horizontal axis. You are taking it to the horizontal axis. So how do you ground your cumulative frequency curve? You always look at your classes. The lower limit of the first class is a 0. This is where you ground your cumulative curve. You don't always ground it at 0. It depends on what was your first class. If your first class was 20 to 30, you ground it at 20. If it was at 1,000 to 1,500, you ground it at 1,000. So you always ground it. Remember, you are drawing it using the upper values. So it means 10 has been used. So the next lower number is a 0 according to the first class. So you are going to ground this curve at 0, meaning this is how you ground it. That is how you ground it. You join the last point to the lower limit of the first class. It's not always to 0, but fortunately or unfortunately in this question, our first value was a 0. So I'm definitely going to ground it at 0. I have grounded my cumulative frequency curve. And when you check carefully, this curve is sigmoid in nature, is S-shaped in nature. All cumulative frequency curves take this type of a graph. So when we say allocate a mark for the shape, we are expecting a shape of this nature for all your exams. This is the type of a graph that we are expecting. But every time you draw it, you start by plotting the points. It will always hang. This one is hanging at 10, 4, which was your first point that you plotted. You only ground it once at the beginning. You don't ground it at the top. You leave the top point as the peak of your curve. You don't bring the top point down. Only the lower point must be grounded at the lower limit of the first class. This is a complete cumulative frequency curve. It stops here. You don't have to go beyond that point. But in terms of the grounding, you'll have to join to the lower limit of the first class. Okay. Right. The next question asks us to determine the median mark, which is given by the formula. We're going back to the positions. We by now know that if you want to find a position in statistics, you take the number of observations, you add a 1. Why do we add a 1? It was discovered that when you add a 1, you locate the actual position that you are talking about. So if I want the median, it's the median value for my distribution of those 40 learners, which is approximately number 20 and number 21. Because when you divide 40 by 2, you are getting 20. So it means if you count the first 20, you will stop at number 20. You count the last 20, your number 21 is also number 20 from the other end. So you are approaching the center from both ends. So you'll find that today is not only one number that is at the center, because the distribution is not an odd number. If it's an odd number, it's easy to identify who is in the middle. But as long as it is an even number, there will always be 2. So in this case, the advantage of a cumulative frequency curve is that you can locate exactly where is 20.5. Whereas in discrete data, you can't locate 20.5 because those are just but numbers listed on a page. On a cumulative frequency graph, the graph is continuous. as you can see, is continuous. You can identify the Mickley number by looking for exactly where is 20,5. You can find 20,5 on the graph reading through the scale. Then you read the corresponding mark, because this is an actual graph. You may not be exact, but you'll be around the actual expected answer. Right, so how do we find the median value? Remember, the word median means you are at the center. It's the Mickley value. So it's going to be half of n plus 1/8 value, which is half of 41, which is 20.5 of the way up. Remember, the vertical axis represents positions. Those are your frequencies. So we want a learner who is in the middle of the distribution. These learners have been asked to line up according to their marks. We want a learner who is in the middle of the distribution. What is their mark? So we start by finding their position, which is half of 40 plus 1, which gives us 20.5. Please, that 20.5 is not 20.5%. It's a position, meaning you'll have to go to your graph and find 20.5, which is this 20.5 there. This is my 20.5 there. So I'm going to draw in broken lines across until I touch the curve here. Then I go down and read. That is my Q2. In as far as the box and whisker diagrams are concerned, that is my Q2, the Mickley value or the median. It's in the middle of our distribution. So that learner who is standing in the middle is learner number 20.5. A cumulative frequency curve allows you to identify that 20.5 position. Then you move across, touch the curve, go down and read the mark. So according to my graph, my mark is approximately 35%. So it means a learner who was standing in the middle of the distribution had approximately 35% in that particular exam. Okay, so how do you determine the median mark when given a cumulative frequency curve or an ogive? You have to find the position first. By applying the formula half of n plus 1, all our positions will attract a plus 1. Total plus 1 divided by whatever you are looking for. If it's a quartile, a quarter of the way up, total plus 1 divided by 4. Upper quartile, total plus 1 divided by 4 multiplied by 3, because it's 3 quarters. That's how you identify positions. If they say 70 percentile, which means 70% of the way up, 70% of 41, then get the position, go to your graph and mark that position and read the answer, because this graph allows you to read the answer. Right, let's proceed. Next, the question asked us to determine the interquartile range. By now we know what is the interquartile range. It's the upper quartile, which is Q3, minus the lower quartile, which is Q1. We are now dividing our way up into 4 regions. And we know the first quarter is called the first quartile or lower quartile. And then the middle one is our median, which is the middle quartile, Q2. And the last one is Q3, which is our upper quartile. Right, according to our formula, the lower quartile mark is given by the formula Q1, position equals 1/4 of n plus 1/8 value of the way up, which is 10.25. We shall go to the graph and mark that 10.25 and read the answer. Then the middle quartile, we already found it. We said it's approximately 35, but we don't need it in the interquartile range. If you understand the meaning of the word range, highest minus lowest of the quartiles. Right. Q3 is the position 3/4 of the way up, which is n plus 1, which gives us 3/4 of 40, which is approximately around 30.75 at the value of the way up. Right. If you go to your graph now and locate those positions, right, these are the positions that we are talking about. Our first position for Q1 was 10.25. So you locate your 10.25 here, then you move across until you touch the graph, you move down and read the answer. It's around 22.5. Then the middle quartile, we got it was around 35. Then the upper quartile, according to positions, it became 30.75. It means you go to your way up, we locate our 30.75, then we move across horizontal, touch the curve, go down, read the answer. So you are going to have your Q1 and your Q3. Your Q1 is your lower quartile, your Q3 is your upper quartile. But how did we get those Q1 and Q3 is the most important aspect of it. You determine the positions by saying 1/4 of n plus 1 is Q1, 3/4 of n plus 1 is Q3. Those are just but positions. The actual mark you are going to read on your graph. Then for you to find the interquartile range. The interquartile range is Q3 minus Q1, which in this case is 47.5% if you read on your graph. And then this is actually the upper quartile. Upper, this one is upper. That's your upper quartile, not lower. Right, the upper quartile mark is 47.5. The lower quartile mark is 22.5. Then when we say interquartile range, IQR stands for interquartile range between the quartiles. Highest quartile is Q3, lowest quartile is Q1 through Q2, of course. So the lower quartile is at 22.5, the higher quartile is at 47.5. The difference between the two is approximately 25 marks. So this indirectly means the gap between the lower quartile and the upper quartile was approximately 25 marks. These are the Meekly observations, leaving out the other quartiles. So these are our Meekly 50, 75 minus 25. So we are focusing on the Meekly 50 learners from Q1 to Q3. We call that the Meekly 50 of our learners. The other 50 are outside. So from Q1 to Q3, from 25% to 75%, that is your 50 percentile of the learners, or 50% of our observations are in there. So what was their gap between the highest and the lowest? We are not now worried about the actual lowest mark and actually highest mark, because those could be outliers of some kind. So we are now focusing in the Meekly 50 of them. We want to study them and see, was there a big gap between them? In this case, the gap was 25, which is fairly big a number from the Q1 to Q3. So in short, how do we find the interquartile range? We need to determine our quartiles, Q1, Q2, and Q3. Of course, for interquartile range, we need Q1 and Q3, upper minus lower, just like any other range, highest minus lowest. So our highest in quartiles is Q3, our lowest is Q1. Subtracting those two will give us what we call the interquartile range. Some books will even talk about the semi-interquartile range. With the semi-interquartile range, you just divide this 25 by 2. It's just a further analysis, half of it. Is it still a high number? Yes, it's still high, 12.5. Still high. It shows that there was a big gap between Q1 and Q3. That's how you interpret a cumulative frequency curve and how you calculate the interquartile range. Okay? So this question says the histogram below shows the distribution of marks scored by 200 learners in an introductory statistics test. Right? We are given a histogram here. The first bar is 12 units high, next one 18, next one 55. Right? The question says complete the cumulative frequency table below. You'll have to complete the table, draw a cumulative frequency curve on the grid provided, use the cumulative frequency curve to estimate how many learners scored above 75. 2 marks, 3 marks, and so on. Now to complete the table, you use your histogram, pick those numbers, and then we complete the table. So we are going to proceed. There is our table. We are going to take all the frequencies that we saw on our histogram. We transfer them, and likewise we are going to take the first 12. It becomes our first 12 on the other side. We keep on adding until we get to 200. So it indicates to us that there were 200 participants in this particular distribution. We have our frequencies that we got from our histogram. It has all the information that we need there. We transfer this to our frequency table. We fill the frequencies. We determine the corresponding cumulative frequencies. From there, we are going to use our graph paper. I'm just but summarizing what we have been explaining. We use our graph paper. Otherwise, you'll get your own worksheet. We use our graph paper, indicate our cumulative frequency, then our examination scores. Then we draw our cumulative frequency curve. We plot our points using the upper values and obtain our cumulative frequency curve. This will earn you 3 marks. 1 mark for the shape, 1 mark for plotting more than actually all points correctly, then 1 mark for grounding. It must always be grounded, and we always ground it at the lower limit of the first class. And when you look at your classes, the lower limit is at 30. So this time around, you are going to ground it at 30. You won't ground it at 0 because our information starts from 30. Then that becomes your graph. Then the next part of the question wanted you to determine how many learners scored 75% and above. So you have to check, look for your 75 on the horizontal for marks. We are given 75% is the mark. So you look for 75, draw your broken line going up until you touch the curve, then you move across and read is approximately 160, 162, thereabout. Then you subtract from 200 because it's all these learners that are here. These are the people that scored above 75. Those are the people that scored above 75. Otherwise, we're going from here 75 up to 100 there. So these are the people that scored above 75. So how do we answer this question? We take the total, which is 200, minus the cutoff point of 75. Up to 75, there were 162 approximately there. Then up to 200 is an extra 30-something learners. That's how you answer that question. So it's going to give us 200 minus 162 approximately. That will give us around 38. So it means approximately 38 learners scored above 75%. So first things first, you construct your cumulative frequency column. Taking from the histogram, you deal with your frequencies, you literally copy them as they are or read on the graph, transfer to your classes, then come up with your cumulative frequencies. Cumulative frequency, you always take the first number, it leads the next class. Keep on adding until you get to the last class. Then from there, you design your Cartesian plane, plot your points, join them using a smooth curve. It will always be an S-shaped graph which needs to be grounded. You ground it at the lower value of each class. Our lesson is going to end here for today, and we are saying in this lesson we learned the following. The grouped data mean is calculated by using the midpoints. The modal class in the class is the class that has the highest frequency, and a histogram is used to represent continuous data. In other words, your bars must always touch each other. A frequency polygon is drawn by plotting midpoints against their frequencies. And then a cumulative frequency curve or an ogive is drawn by using cumulative frequencies. The median, lower quartile, and upper quartile values are calculated by using the formula for positions, which is half of n plus 1/8 1/4 of n plus 1/8 and 3/4 of n plus 1/8 respectively, in that order, right? Then here is a worksheet that you'll have to go through on your own and practice these questions. Is worth 15 marks. Length time in minutes of a certain number of telephone calls was recorded. No call lasted 25 minutes or longer. A cumulative frequency table for this data is shown. There is a cumulative frequency table. It was drawn for you, grounded at 0. You need to start this diagram and answer the questions that follow. You shall receive the worksheet. You shall come back to the presentation. You will find this worksheet towards the end, and then answer, complete this table. This time you are reversing from the cumulative frequency to find, the frequency curve to find the corresponding frequencies, just like you did with a histogram. Then hence, draw a histogram and then answer all other questions. There is your question number 2. It's a cumulative frequency table. You need to determine your cumulative frequencies and then answer those questions that follow. Otherwise, our session ends here for today. And thank you for attending. Thank you for coming. Go and practice as much as you can. You love these questions and collect a lot of marks. Otherwise, thank you and goodbye.